Hi, this is part of the instructional video series for the Strategic Decarbonization Assessment Tool, or SDA Tool, which is being used for the NYSERDA Empire Building Challenge program. This is video 4 of 4, and in this section, we'll be reviewing the Scenarios tab, which is where you'll plan out measures and the implementation schedule for each scenario that you've defined and view the results. The Scenarios tab is generally separated into two sections. On the left are a series of tables where you'll assign measures to each of the scenarios that you're looking at. And on the right are a set of graphics in which you'll be able to review and compare the results between the different scenarios. Beginning the scenario analysis, you'll need to choose a standard NPV analysis time period, 5, 10, 15, or 20 years, probably matching to your facility's holding period. You'll also pick the year that the analysis begins. As mentioned previously, the tool automatically creates two baseline scenarios. These represent your building's current operation carried forward into the future, with the only activities being standard maintenance, as well as replacement of current equipment like for like, with minimally efficient similar equipment at the end of its useful life. There are two baseline scenarios, one which corresponds to a reactive fines approach to compliance with Local Law 97, and one which corresponds to compliance with Local Law 97 through purchasing offsets. Starting in the first baseline scenario, reactive fines, you'll see here a couple of sections. At the top, immediate repairs and deferred maintenance. Here, the tool automatically takes any ECMs that you labeled in the previous tab, Narrative and Measures, as immediate repairs or deferred maintenance, and automatically brings in the savings, costs, and other data associated with those measures. You'll need to select the year that these measures will be implemented at your facility. The tool automatically also pulls in equipment data for equipment with less than 5 years remaining useful life and between 6 to 10 years remaining useful life. It pulls this information from the Equipment Inventory tab that you previously filled out and inputs the savings, costs, and other data associated with this like-for-like equipment replacement. As before, you'll need to put in the year that that equipment will be replaced. Finally, this baseline scenario calculates the difference between your building's performance and the Local Law 97 requirements for carbon emissions, and automatically calculates the fines associated with noncompliance. The next baseline scenario, offset-based compliance, is identical to its twin in every way, with one exception. This particular scenario also calculates the difference between your building's operation and the Local Law 97 emissions requirements. But it calculates then the costs associated with proactively purchasing carbon offsets in order to meet those targets and adds that in to the scenario results. In addition to the two baseline scenarios, you can complete up to 3 alternate scenarios for your facility. Scrolling down within each scenario, you'll be able to name the different ECMs that you're considering at your facility, and then pick from a drop-down menu all of the ECMs that you entered previously on the Narrative and Measures tab. The tool will automatically input the savings, costs, CapEx, and OpEx associated with that ECM. You'll be able to input the year that you want this ECM to be implemented. And in this way, you can consider phasing at your facility. At the bottom of each scenario, you'll then have an option to offset the remainder of the carbon between your building's planned performance and the Local Law 97 requirements in order to meet those requirements. So if you click yes here from the drop-down menu, then the tool will automatically calculate the amount of annual carbon offsets you'll need to purchase in order to meet those targets. If you click no, then the tool will automatically assume that you're not going to meet Local Law 97 compliance and will calculate the fines associated with non-compliance given this scenario's performance. Again, you can fill up to 3 different scenarios. As discussed previously, here, for the purposes of this example, we filled out 3 different scenarios. The first representing rapid, deep electrification retrofit, replacement of all gas and steam using equipment with efficient electric equipment, as well as some standard energy saving measures. Scenario 2 corresponds to phased compliance with electrification. It also looks at fuel switching from current gas and steam using equipment to efficient electric equipment, but on a longer time frame. And then finally, scenario number 3, here for the purposes of this example, assumes efficiency only related ECMs, looking at low cost and no cost retrocommissioning and standard savings measures, but making no real effort towards electrification specifically. Once you've filled out your scenarios, then it's time to look at the results. And the results include both energy, carbon, and financial data for your facility forecasted for each of these scenarios. The first graphic shows the relative net present value of each of the scenarios. Note that this is the net present value at the time period that you selected initially. So if you want to look at the NPV for different time periods, just go back over to the left side of the tab and pull a different time period from the drop-down menu. Note that this also assumes the discount rate that you entered back in building info and assumptions. In addition to relative NPV, the tool then charts out the estimated net operating income per year for your facility under these different scenarios, as well as the estimated net operating expenses per year under these scenarios. And if you want to have a closer look at your results, you can always click on the vertical axis and adjust it in order to zoom in a little bit and be able to see the differences between the scenarios more clearly. The outputs also include energy and emissions data. This graphic shows the expected energy use index, or EUI, in kBTU per square foot per year for each of your scenarios going forward, based on the ECMs that you've selected and their phased implementation dates. You can see here that by implementing ECMs on different timeframes, you achieve levels of performance across a long time horizon. One item to note here, you may notice that for some of these scenarios, the energy use index decreases for a period of time before rising back up again. This is because some ECMs have a limited lifetime. For example, a retrocommissioning or tune-up measure is generally going to only achieve savings for a year or two and needs to be completed more frequently in order to ensure consistent, durable savings. If you want to have a measure that's either implemented multiple times over a long time period, such as equipment replacement that happens frequently, or a measure that happens annually, such as retrocommissioning, there are a few ways to represent that in the tool. I'll show you a few that I suggest. For a measure that you want to implement multiple times, for example, replacing a piece of equipment at year 5 and then again year 15, you can go back to the selected scenario and pick the same measure from the dropdown. For example, here, replacing steam with a heat pump system, but have different years that the ECM is implemented. And this should then show up in the results. For a measure that you want to implement annually, like retrocommissioning, what we suggest is to go back to the Narrative and Measures tab. And under that measure, for example, here, tuning up VAV boxes, dampers, and coils, set the measure lifetime for a long period of time, or however long you intend to implement the program. Let's say here, 15 years. Then, instead of indicating a CapEx for the measure, indicate an energy or a non-energy related annual cost associated with that measure. For example, if you do retrocommissioning or tune-up every year and it costs $10,000 annually, in this cell, you would indicate a negative value for a cost of $10,000 per year. And this will then be carried forward into the tool in the results. Going back to the outputs, in addition to EUI, we show the carbon emissions per year, both before and after offsets for your facility, as well as comparing your building's performance against Local Law 97 requirements. This graphic shows the carbon emissions per year before offsets. So you can see here pretty clearly that in your baseline scenarios, you really don't have a lot of variation in terms of emissions at your building. Whereas in your alternate scenarios, you see decreasing or changing emissions over time, especially those associated with fuel switching. The black dotted line indicates the Local Law 97 limits for your building based on its fuel mix and its size and building type. Note that right now, the Local Law 97 limits are set for two time periods, 2024 to 2029, and then again 2030 for 2034. There currently aren't requirements set for Local Law 97 limits past 2034. So this data here, 2035 and past, is just for an example. You can also see the net carbon emissions per year with offsets, which allows you to see how offsets can allow your facility to meet the Local Law 97 requirements over time. Finally, a last set of graphics. This graphic shows the net present value of your various scenarios on varying time horizons. Each of these bars represents the 5-year, 10-year, 15-year, and 20-year NPV for your scenario. Here, you can see, depending on how you set up your scenarios, how that time horizon can really make a difference in terms of the net present value. For example, scenario 1, which we've set up as deep decarbonization retrofit, includes a bunch of measures that involve replacement of long life, but very expensive equipment at your building. On a short time horizon, 5 years, 10 years, those measures don't necessarily pay back for themselves. But on a longer time horizon, 15 years, 20 years, they do. Of course, you should select the NPV that reflects your asset holding period or your standard analysis period. And if you have a period that's in between some of these 5-year, 10-year, 15-year increments, you can just interpolate between the results as necessary. Finally, we have a graphic that shows the net present value associated with your utility savings or energy savings at the facility, broken into both consumption-based savings, kilowatt hours, therms, pounds of steam, etc., versus peak demand-based savings, kWs. And finally, a graphic indicating the annual fines and the offsets paid under each scenario. And here you can see the difference in terms of the costs of fines versus the cost of offsets. Right now, as of the time of this recording, the Local Law 97 fines are set at $268 per ton of carbon equivalent, whereas offsets are generally available for between $15 to $30 per ton. So offsets are, at this time at least, probably cheaper than paying the fines. You'll notice also as well, if we go back to one of the scenarios and say, you know, I don't want to offset the remainder of my carbon to meet the Local Law 97 requirement, I'll just pay the fine, and you select no from this dropdown, the tool will automatically calculate those fines into the scenario, and that'll show up here in this graphic. That's the end of the scenario tab. Before closing out, I want to call your attention to a few other tabs and components of the tool. There are a number of tabs in the tool that are hidden and that may be hidden at the time that you receive the tool or in the version of the tool that you receive. And generally, these contain reference information as well as background calculations. I want to call out two hidden tabs. One is a summary tab. which includes a table of savings, costs, CapEx, OpEx, NPV, and progress to zero net carbon for each of your scenarios. It contains a set of those graphics from the Scenarios tab, and it also includes tables of standard building financial characteristics from your building info and assumptions, as well as your building's initial energy and carbon characteristics and Local Law 97 compliance assumptions. The purpose of this tab is to have an easy printable in order to print out and show to others or use to present. Another tab that may or may not be visible is the Operating Statements tab. And this is where most of the calculations occur for the tool. It sets up operating statements for each of your baseline and proposed scenarios, and also contains a bunch of background calculations for the net present value, EUI, carbon emissions, fines, and more. Generally, we recommend that you don't try to edit anything on this tab because it potentially will affect the calculations throughout the tool. But the information is here if you need to reference it. And that's the end of the review of the Strategic Decarbonization Assessment tool for the NYSERDA Empire Building Challenge program. Thank you.